Hello students, we are down now to our last topic, which is all about sound. In this topic we have how sound is produced, pitch and volume, sound and materials, and musical instruments. At the end of this topic, you are expected to know that sound is produced when something vibrates. Know the different parts of a sound wave, know pitch and volume, know that sound travels through some materials, and know how to change the pitch and volume of a given musical instrument. For today, we're going to explain 6.1 how sound is produced. But let us have first a short review. In our previous topic, we dealt with the two movements of Earth, rotation and revolution, their differences and effects on Earth. I have here some bubbles of statements. Now, what I want you to do is to identify each statement, whether it refers to rotation or revolution. To start with, we have the first one. The sun is in the east in the morning, in the west in the evening. So this is caused by rotation or revolution. It is rotation. Second, takes 1 year to complete. Rotation or revolution? We have revolution. Next, follows a path called an orbit. It's revolution. Causes day and night. Yes, rotation. When the Earth is facing towards the sun, it is daytime. Again, rotation. Occurs in 1 day. Rotation. Causes the seasons. Revolution. The movement of Earth around the sun. Revolution. Takes approximately 365 days. Yet again, revolution. The spinning of Earth in its axis. Rotation. And lastly, takes 24 hours to complete. We have rotation. I hope you got all the answers correct. Now, let's go now to our new lesson. The question is, how sound is produced? Before we answer the question, how sound is produced, let's answer first this one. What is sound? Now, is sound a matter? It is not. Sound is not a matter because it has no mass and volume. When we say mass, it refers to something an object is made of. And when we say volume, it refers to the space the object occupies. Now, can you think of another examples of non-matter aside from sound? Did you say light, heat, electricity, or lightning? Those are some examples of non-matter, the same as sound. Now, if sound is not a matter, then what is it? Is it an energy? Yes, it is. Sound is a movement of energy through substance like air and water caused by vibrations. And what is this vibration? Vibration, it means moving quickly back and forth about a point. We are talking here about particle level. So that means the particles of the object, they are moving back and forth. And because of this, we can hear the sound. Now, to show you an example, we have here a cymbal. Now, observe how the parts of the cymbal move back and forth as it was hit by the stick. Now, to give you an idea on how that sounds look like, okay, the sound that you heard, this is the energy that is moving through the particles by the vibration of the said particles. Next, is sound a wave? Yes or no? Yes, it is a wave. Sound travels in the form of wave that results from the vibration of the particles of the medium. And when we say medium, we refers to anything that is solid, liquid, or gas through which the sound travels. Now, unlike light, which can travel without a medium, sound cannot travel without solid, liquid, or gas. So that means sound cannot travel in the outer space. So if an astronaut is in the outer space, so he will not be able to hear the sound unless he or she will have a gadget to help him or her. Now, to give you an idea on how the sound wave looks like, so observe the guitar, the strings of the guitar, how they make a wave pattern as they are being played. That's how sound wave looks like this one. So of course, different sound will have different sound wave pattern. Sound wave have different parts. If you had already read the notes, then you are already familiar on what are these parts. To start with, let's have A and B. Now, what do you think is the name of this part? They are just the same part of the wave. So we have the crest. Now, what is crest? When we say crest, we are talking about the high point of the wave. Now, if there is a high point, of course, there will be low point. We have C and D. Now, what is the name of these low points of the wave? We have trough. Again, trough is the low point of the wave. Now observe these distances in the wave. We have from crest to crest, from trough to trough, and at the middle in the rest point. Now when we say rest point, it means it is the point in the wave wherein there is no sound. That's why It is called as the rest point. Now, what do we call these distances? We call them wavelength. It is the distance between two successive crests or troughs. When we say successive, it means it happened one after the another without a break. So that means from crest to the next crest, and from trough to the next trough, and also in the rest point. We call that wavelength. The next distance we have is the distance between the rest point and the crest, and the rest point and the trough. And these distances, we call them amplitude. The amplitude is the distance from the rest point to the crest or trough that shows the amount of energy the wave has. So that means it is the height of the wave. The higher the height, then the more energy the wave has. That means the louder the sound, and then the shorter the height of the amplitude, that means the less energy the sound wave has, so it will be a softer or a quiet sound. Next, how many waves do you think our diagram has? In order for us to be able to count how many waves a sound wave has, we need to count one crest and one trough, successive. So that means from here and to here, so we include one crest and one trough, that is one wave. And next, that's the second wave. If we are going to count the number of waves in a given sound wave or in a given time, then we are talking about frequency. How much wave the sound wave has. So frequency is the number of waves in a given time. Okay, let's see if you understand what we have discussed. I have here a sound wave and the parts are labeled, and all you have to do is to identify what is the labeled part. To start with, let's have letter A. So what is the name of part A? It is crest, the high point of the wave. How about B? Amplitude. It is the height of the wave from the rest point to the crest, or from the rest point to the trough. How about C? It is from trough to trough. We have wavelength. And D, the low point of the wave, is known as the trough. Next, identify what is being described. For the first one, it is the distance between the resting point and the crest or trough. What is being described here? The answer, amplitude. Second, it is the high point of the wave. Did you say crest? Then you are correct. Third, it is the number of waves in a given time. Frequency. Fourth, it is the distance between successive crests or troughs. Wavelength. And lastly, it is the low point of the wave. Trough. Oh, there's the sixth one. This is the one, finally. It is produced by the vibrations of the particles. We have sound. Okay, based from our explanation a while ago, you are able to answer now how sound is produced. Okay, give it a try. What do you think is the answer in this question? Did your answer include the word vibration or vibrate? Then your answer is correct. Sound is produced because of the vibration of the particles, or sound is produced because the particle vibrates. We already know now that or how something makes sound. Now the next thing is how we are able to hear the sound from the source. Of course, we can hear the sound using our ear. But how does the ear hear? Here are the following steps on how we can hear the sound from the source and what is happening inside our ear. So to start with, we have number one. Okay, the first one we have here, this is the part. Okay, we call this one pinna or earlobe. Now the sound waves are collected by the earlobe or the pinna. So this is the reason why our ear shapes like this, in order for it to collect the sound waves. Then the second one, the waves travel along the ear canal. So this is our ear canal. Okay, so from the pinna or our earlobe, the sound waves will travel here. Of course, it is the air particles that is vibrating, because inside here there are some air particles. Next, what do we call this part of our ear? Call it eardrum. Now the waves make the eardrum vibrate. So the vibration, because of the energy, is being passed on to our eardrum. And then connected to the eardrums are the small bones or the ossicles. The small bones or the ossicles amplify the vibrations. When we say amplify, it means it makes the sound stronger, or it makes the sound louder. Okay? So in this part of our ear, it's where the smallest bone is located. The next one, the cochlea turns these into electrical signals. Now the cochlea here, this one, the twisted tube, it is our main organ for hearing. And because of this part, the vibrations are being turned or changed into electrical signals. And these electrical signals are being transmitted by our auditory nerve. So it is the nerve that is connected to the cochlea, and auditory, it means it refers to sound. It takes the signals to the brain, and our brain will be able to identify what is the sound we are hearing. So that's it. How does the ear hear? From the sound waves to our earlobe, then travels to the ear canal that will make the eardrum vibrate. Then the small bones or the ossicles will make the vibration louder or amplified. And then the vibrations will go to the cochlea, which is the main organ for hearing, and it will turn the sound waves into electrical signals. And these electrical signals will travel into our auditory nerve to the brain, and the brain will be able to analyze. This is how it looks like. Okay, what we have learned so far. First one is, we know now that sound is a movement of energy through a medium caused by the vibration of the particles. Second, sound travels in the form of wave, and the parts of the wave are crest, trough, wavelength, and amplitude. Application. Below is a tin can telephone. It is made by attaching two tin cans with a string. Explain how she was able to hear the sound made by the boy. What do you think is the answer? We have his voice caused vibrations that travels from his tin can to the string, then to her tin can into her ear. So that is how she was able to hear the sound. I hope you understand the lesson for today. Thank you for listening. Have a nice day. Goodbye.